This is Geometry, Unit 3.4b. Talking about proofs about lines and angles. This is day number 2. First thing we want to mention is a linear pair. Yesterday we learned about supplementary angles, and supplementary angles are two angles that add up to 180. Yesterday we also learned about adjacent angles, and adjacent angles have the same vertex and they share a side. So this is an example of adjacent angles that are also supplementary, that form a straight line, that add up to 180. So this is an example of a linear pair. So if we put the letter E here at the edge, we could say that the measurement of angle ADC plus the measurement of angle CDE, that adds up to 180. They are supplementary angles. That is a linear pair. Notice that a linear pair is a straight line that has a ray coming off of it. What we're going to say in our proofs, in the future you're going to need to write this in your proofs. If two angles are a linear pair, that could be given information to you. So if two angles are a linear pair, then they are supplementary. You have to go through supplementary first. Then you would say, if two angles are supplementary, their sum is 180. But if you know you have a linear pair, you first talk about supplementary. Another pair of angles are vertical angles. My picture's got a little messed up here. But if we extend those out, vertical angles are when two lines make a big X. They are the angles that open in opposite directions. Even over here, if we extend these lines out, they're the angles that open in opposite directions. Those are vertical angles. So if I have a big X, and we'll call this, let's say 50 degrees, what could be the measurement of the one next to it? If we know this is a straight line, we know the two angles side by side that make up that straight line. If it's two angles that are adjacent, these are called a linear pair. So what would be the measurement of this one? Be 130 degrees. Now if you come down and you look at a different pair of angles, you look at these two, what would this angle be? That would be 50. That adds up to 180 degrees. Now notice what happens. Look at these opposite angles. The opposite angles are the same measurement. We would first call them congruent. That's the first thing that you should think of. Vertical angles are congruent. So they're going to be equal in measure. And then if you look here at this pair, this is a linear pair side by side that forms a straight line. What's this measurement going to be? That's 130 degrees, because 50 plus 130 makes that straight line. Adds up to 180. Plus, we also know that vertical angles, angles that open in opposite directions, formed by two lines that are crossing, those are going to be congruent. They're going to be equal in measure. So what we say in our proofs, if two angles are vertical, then they are congruent. We have to say they're congruent. We cannot just say that they're equal. We first say congruent, then we can move on to say if angles are congruent, then they're equal. But vertical angles are always congruent. So we're going to look at example number 1. Over here, we're going to extend our line a little bit. So this is angle 5. This is angle 6. This is angle 7. And this one out here is angle 8. So what do we know? What would we call? We're looking for vertical angles, a linear pair, or neither. Those are your 3 options. So angles 1 and 2. What type of angles do 1 and 2 make? What you would want to do you would want to trace out what that angle is. That's this angle here. And you would want to trace out the angle next to it. That's this angle here. And what do you know about those 2 angles? Are they forming a big X? Those are side-by-side neighbors. They are not a big X. So what type of angles do we call these? Are they vertical angles because they form a big X? Are they a linear pair because they're side by side and add up to 180? They are a linear pair. Letter B, 1 and 3. When you look at 1 and 3, and you trace out angle 1, we're looking at this angle up here for angle 1. Then you trace out angle 3. That would be this angle down here. Do you notice how those 2 angles are making a big X? And the angles that we're looking at in that big X are going in opposite directions. So what type of angles are those? Those are vertical angles. How about 1 and 4? Linear pair. They are side by side and they form half of a circle. How about 4 and 5? Vertical angles, remember, they have to have the same vertex. Linear pair have to have the same vertex. So when we look at angle 4 and angle 5, they don't have the same vertex. So that falls under neither. How about 4 and 2? Those are vertical angles. 5 and 8. Okay, let's take a look. 5 is here. That's angle 5. Angle 8's way over here. So they don't have the same vertex. They don't make a big giant X. Vertical angles make a giant X. Linear pairs are the same neighbors. So they fall under neither. How about 5 and 7? So that's neither. 5 and 7 have different vertices. 5 and 6. Five and 6 are side by side. Angle 5, if you trace out angle 5, you can trace it out with your eyes, you can trace it out with your finger, you can trace it out with your pencil. And angle 6, notice how they don't make a giant X. They're almost making a T type shape, but this one's upside down. So those are a linear pair. They are side by side. So here we have our picture. We're going to redraw that right over here so we can write on it. We know that angle 4 is supposed to be 63 degrees. This one would be angle 1, 2, and 3. We're using numbers for the angles, just it's a little bit easier to say what they are and read what they are than using all the letters. Letters get a little complicated sometimes. So if angle 4 is 63 degrees, how are we going to determine what angle 1 is? Yeah, angle 1 and 4, we know. The first thing your mind's got to realize is that angle 1 plus angle 4 adds up to 180. Then we're substituting, like we did in yesterday's notes, we're substituting in the 63. Then we can subtract across the 63 and we get 117 degrees. So angle 1 is 117. How about the measurement of angle 2? Okay, the measurement of angle 2 is going to equal the measurement of angle 4. So the measurement of angle 2 is going to equal 63 because we substitute in the 63 to the 4. So that is 63. And how about angle 3? Because we know the measurement of angle 1 is going to equal the measurement of angle 3. And 1 is going to substitute in 117. So those are our 3 measurements we're looking for. Let's try that again. We'll come down here, we'll redraw in our picture. We know that angle 3, this is supposed to be the one on the outside, is 121 degrees. This would be considered angle 4, angle 1, and angle 2. So what's a relationship we know for sure? How about angle 2 and angle 3? What do we know about angle 2 and angle 3? Angle 2 and 3 are going to be a linear pair. They're going to add up to 180. So the measurement of angle 2 plus the 121, because we're substituting in, because we know that angle 3 equals 121. Then we subtract it across, and we get 59 degrees. So angle 2 is 59 degrees. So what's the measurement of angle 4? Angle 2 is going to equal angle 4. So if angle 2 is 59 degrees, the measure of angle 4 is 59 degrees. Because they are a linear pair. And the same idea, the measurement of angle 1 is going to equal the measurement of angle 3, because they are they are vertical angles. Vertical angles are across from each other. So the measurement of angle 1 is we'll substitute in our angle 3 amount, which is 121. So angle 1 is 121 as well. Okay, when we come down and look at a figure like this, we're not told what type of angles these are. You've got to look at the information. You've got to decide what two angles to work with. Looks like we're going to work with these two because we have degree values for them. So I know by looking at those that the measurement of angle FKG, you got to use your eyes, your pencil, or your finger. FKG plus the measurement of angle GKH has a relationship that adds up to 180 degrees. They are a linear pair. Those two angles are supplementary, so they add up to 180. Now I'm going to substitute in our two values. I'm going to group our like terms together. Notice here that we are not adding 1 to the 113. We're not doing the opposite sign. Because they're on the same side of the equal sign, they're all on the left-hand side, we're just going to do exactly what it says. A negative 1 and a positive 113 is now 4x plus 112. Now we'll go to the opposite side of the equal sign, so we have to do the opposite sign. That's 68 degrees. What would we do from here? Divide by 4. Divide by 4. So x is going to equal, the 4's crossed out. 4 goes into 6 one time. That would leave us 2 left over. So 4 goes into 28 7 times. So x is going to be 17. You don't need a calculator for every calculation. If you have the 4 on the bottom, 68 divided by 4, so you can see them a little better. First, think about these two. So 4 goes into 6 one time. But there's extras left over. It goes in there 2 times. So I put my 2, I carry my 2 over because we haven't used that extra 2. So now we're looking at 28. So if you know your factors, 4 goes into 28 7 times. So that's how you can do some of these calculations without being dependent on a calculator. So over here, this is going to be 3x plus 4. That's in parentheses. We can call this AB or AEB and CED. Now, when you look at these two angles, you need to identify what type of angles those are. What's their relationship to each other? What type of name would these two angles have? These two angles are vertical angles. And what we know is if vertical angles, then congruent angles. So we know that these two angles are going to be congruent to each other. They're going to be equal in measure. So I can say that the measurement of angle AEB is going to equal the measurement of angle CED. You want to get used to thinking in that process and writing it out in that pattern. So this is 4x minus 18 and 3x plus 4. Now it's just an algebra problem where we group our like terms together. Because we're going on the opposite side of the equal sign, we have to subtract it across. I'm going on the opposite side of the equal sign, so I'm going to add the 18 across. This gives me x, and this gives me 22. So this x would have to be 22. When we look at a figure that has x's and y's involved, I would suggest at paying attention to which angles have the same variable. These two angles are a linear pair. They make 180 degrees. So you know that 16x plus 9x plus 5 equals 180 degrees. You group up your like terms. You subtract across your 5. And we can divide. So that's going to be 7. X would be 7. Well, if x was 7, we can come in here and say 9 times 7 plus 5. That is 63 plus 5. This is going to be 68 degrees. So now we know what the 4y is supposed to equal. See how we did that? We figured out our x because we worked with the angles with x's. Then we're going to set the y's equal to each other. Once this value, we took our 7, we plugged it in, we figured out 68, so 4y equals 68 because those are vertical angles. So 4 goes into 6 one time with 2 left over. Hey, that's 17 again. Same exact calculations we had before. On this side over here, which two angles should we look at first? What pair of angles? How are we going to write an equation here? What do you see? 9x plus 2, and you know you have a 10x minus 7. What's their relationship to each other? They both have x's, and they are vertical angles. If vertical angles, then congruent angles. So those are vertical angles. So we can say that 9x plus 2 is going to equal 10x minus 7. That gives me x, add my 7, add my 7. So x has to equal 9. We could do the same thing with the y's. The y's are also vertical angles. So you would equal them to each other, and then you would solve your algebra. In terms of time, let's flip it over. Let's take a quick look at our one example of a proof. J, K, L, and M. This got cut off a little bit. What we're pointing out right here is that if you have right angles, two right angles are going to be congruent. And the way that we can show that is that if K is a right angle and L is a right angle, that's our given information. So K, angle K, comma, angle L is a right angle. Angle K and angle L are a right angle. That means they add up to 90 if right angle, then 90 degrees. That's what the definition of a right angle is. That's right here. If an angle is a right angle, then its measure is 90. That's what we pretty much said there. We have our transitive property. Here we have two things that equal 90, so the two things are also equal to each other. So the measurement of angle K is going to equal the measurement of angle L. That's the transitive property. If equals, then congruent. Notice how these K and L are equal to each other. Now we're going to call them congruent. If comes earlier, then comes right now.